Hello, I am Dr. Andy Hales at the University of Mississippi, and in this video we are going to look at how to do basic descriptive analyses in R. So diving right in here, we're going to be using the tidyverse and janitor packages, so if you haven't already installed those, make sure you get them loaded up here. And we'll read in the data and select the columns that we're going to be working with. And we can see that today we've got participants with their own number, and here we have this this variable of fear. Now this is a nice categorical variable. We asked participants what their greatest fear is, and we gave them 4 options: loneliness, spiders, etc. And so each person selected just one of those, and they also estimated the number of Skittles in a regular bag. So we've got a nice categorical variable that we can perform counts and percentages for, and a nice quantitative variable here where we can see how it's distributed, calculate the mean, and so on. So to do that, we'll start with this categorical variable. And the best way to get our heads around that is with the good old-fashioned frequency table. So in R, a quick and easy approach here is to use the table function. You just give it the name of the column you're working with, and it's a good idea to tell it that you do want to use the missing values so you can become aware if there are any missing cases. Better to know than not know. And sure enough, there's one missing case, but more importantly, the substance of the result here tells us that of our 49 total observations, 29 people indicated loneliness as their greatest fear. Bizarrely, no one is afraid of pirates. Don't know what that's about. But we've got raw frequencies here. We're good to go. However, usually it's informative to know as a proportion of the total group how many people are picking each. So percentages are really valuable, especially when you have larger data sets. So if we want to know percentages, we just feed this result here into prop.table. So again, that's using this pipe operator that takes everything on the left and then performs the operation on the right. So let's take the proportions of this table. And when we do that, we see that out of our sample here, 59% of people indicated loneliness is their greatest fear, and 6% of people indicated it was pirates, and so on. Cool, quick and easy, it works, but it would be convenient to see the percentages and the raw frequencies side by side. And thankfully, this table function from the janitor package does that in a very easy way. So we take our data and then perform the table function on it, with the fear being the column we're looking at, and we get the side-by-side percentages and raw counts here. So 29 people indicated loneliness was their greatest fear. You'll notice here, percentage is given to us in 2 different ways. We've got the overall percent, 59% of our total 49 observations chose loneliness. But then to the right of that, we have valid percent out of those who provided a response. So ignoring that missing value, what was the percentage? And there we see it's slightly different. 60% indicated loneliness. So depending on your immediate goals and what's more relevant to you, you'd pick which one of those to interpret. Okay, so frequency tables are fine, but we're humans and tables are super boring, and figures an image is worth 1,000 words, all those cliches. Let's look at this thing. Pie charts are a very popular way of breaking down categorical data like this. So let's look at a pie chart. Now, this is a lot of code. I get it. Don't panic. Up till this point in the series, I've been going through line by line and sort of explaining what everything does. We're reaching the point here where I'm going to ask you to trust me that this does what it's supposed to. This uses ggplot, which is an amazing playground of wonderful features, makes great graphs. It's worth learning on its own, but that's a separate project. So here we take the data, we get rid of the missing values of fear, and we feed that into this ggplot code, and it produces a pie chart. And the pie chart confirms what we saw in the table, and it conveys to an audience pretty quickly here that the majority of cases, by far the largest group here, is loneliness. Nice. Now, we might prefer to present this as a bar chart. and we could do this as a regular bar chart, not a stacked one. That's coming up in a second here. So just as a regular bar chart, it would look something like this. Now, same data presented differently, sort of dealer's choice, which you prefer. Pie charts get really difficult if you have many categories, so then a bar chart might be better. However, there is one feature of this bar chart that I simply don't like, and that is that the percentages are shown side by side, which in this case is strange because these are mutually exclusive and exhaustive categories. They should sum to 100. And putting the bars separately makes it feel as if some of these could be taller without the others being shorter, which is not the case. If more people selected one, then fewer would have had to select another. But that's easily fixed. We just take these bars, throw them on top of each other, and then it immediately becomes clear that these are proportions of a whole. So I like the bar chart in this case, and this may be more graceful than pie charts in handling many categories. You have options here. There's no right or wrong approach. There you go. Now, we're on to continuous data next. Remember, we have these estimates of the number of Skittles in a bag. We'll start again with numeric summaries of this. The quick and easy way to do this is with the summary function. We feed that the name of the column we're working with, and we get what we saw earlier. A nice overview here. We have the minimum, the maximum, median and mean, and also the lower and upper quartile ranges. This is good, but you'll notice it's missing a common statistic that we usually like to include, especially in psychology with the basic descriptives we're giving people, which is the standard deviation. It's not included in this table. That's okay. The standard deviation is simple enough to calculate on its own using the SD function. And when you run that, you see standard deviation is 18.71. And if all those extra digits irritate you, then you can just round it off to 2 decimals using this code here, and it is a little easier on the eyes. Cool. Nothing wrong with that. Quick and easy, gets the job done. However, if we use this tidyverse approach I'm about to show you, we unlock the ability to also break this down by group. So if we want to look at the estimates separately for, say, a control group versus an experimental group, or look at men versus women's responses differently, this lets us do that. Or, in our case, we have this group right here of people who are afraid of loneliness versus people who are afraid of pirates versus spiders, and so on. So, for starters, let's ignore the group by part. Let's just look at how we would get the overall summary statistics using the tidyverse approach here. We take our data frame and then summarize it such that the mean is equal to the mean of estimate, the standard deviation is equal to the standard deviation of estimate, and the n is equal to the n. We run this and we get the same results as above. However, now if we tell it to group by a categorical variable, we get the same results, this time broken down by group. So among those who indicated that loneliness is their greatest fear, the mean estimated number of Skittles is 45, and the standard deviation is 17. Now, we might trust that estimate a little more because there were 29 observations leading into it, whereas the number of people who are afraid of pirates had a mean estimate of 66, but that mean is based on only 3 observations, so probably not a lot we want to draw from that. Of course, you'll notice here NA is included also, and it must be the case that whoever selected NA thought that there were 100 Skittles in the bag. So that's good for us to be aware of, but overall we get the picture of what's going on there. So again, tables are nice. I'm happy to see these numbers. You're going to need to be able to generate those, but figures are helpful for seeing how these things are distributed. And so we've already seen a handful of times that a very quick and easy way to see a distribution is with hist for histogram. And here we can see most people think that the number of Skittles is somewhere in here with bins between 20 and 60. That's great, but then up here we have the slight positive skew. Some people think there's higher estimates. Cool. Also kind of ugly, so we could use ggplot to make a nicer looking histogram, and I'd say that's an improvement. However, again, like above, the real asset we're buying here is the ability to break this down by group. And the way we do that in ggplot is with different facets. So imagine this histogram here. We want to create different panels for the different subgroups. Well, those are called facets. And here we want to build those facets based on fear. That sounded scarier than I meant, but broken down by the fear groups, and you can see that we now have histograms for each of the fear groups. Loneliness is the biggest group, so we shouldn't be shocked that there's more responses up here. We even have a histogram for our 1NA group. Again, that's not super useful, and if we wanted to tidy that up, we could get rid of it elsewhere. But I'm sure you can imagine cases where it is desirable to see these different histograms broken down by group. So there you have it. That is how you do basic descriptive analyses in R. I will see you next time.